the graph of f prime on the interval -3 to 2 is shown in the figure. So this is the graph of f prime. This is the graph of the derivative, f prime. On what intervals is the function f increasing and decreasing? Okay, so there are some important points here again, at -2 and at 0. And those are the places where the derivative is 0. -2 and 0. So these are the critical points, the places where the derivative is 0. Okay, so before -2, this part of the graph, the derivative is below the x-axis. Between -2 and 0, the derivative is above the x-axis, and after 0, it's above the x-axis again. So what that means is if the derivative is negative, the function is increasing. If the derivative is negative, the function is decreasing. If the derivative is positive, the function is increasing. So we will say it's increasing from -2 to 0 and 0 to 4, because I'm stopping at 4. And then it's decreasing from -3 to -2. Okay, it says find the critical points of the function. So the critical points are places where the derivative is 0. So there are critical points at x equals -2 and x equals 0. Which critical points correspond to local maximum, local minimum, and neither? So remember, it's a local maximum if it's increasing and then decreasing. It's a local minimum if it's decreasing then increasing. And it's neither if it just stays the same. So what we notice here is that from at -2 here, at this critical point, it's decreasing and then increasing. So this is a local minimum. At 0, though, it's increasing and then increasing again. So this is neither. It's not a maximum or a minimum. Okay, so now we're going to do another analysis. Remember, this is the graph of the derivative. And I want to talk about the inflection points and the concavity. And so I want to talk about the second derivative. So I'm going to do some more analysis to talk about the second derivative. This is the graph of the derivative, so the second derivative is the derivative of this. So if I was going to think about what the derivative of this function would look like, I would say this function is increasing from -3 to -1. It's decreasing from -1 to 0, and it's increasing from 0 to 4. So what that would mean is that its derivative, or the second derivative, is positive from -3 to 1. It's negative from -1 to 0, and it's positive from 0 to 4. So that tells me that there are inflection points at -1, because the second derivative changes from positive to negative, and at 0, because the second derivative changes from negative to positive. So at x equals -1 and x equals 0. So again, I'm looking at the derivative of this picture, and so this is how we got all this stuff about increasing, decreasing. So, and it relates to the second derivative. Okay, so if the second derivative is positive from -3 to -1, then the function is concave up from -3 to -1. It's also positive from 0 to 4, so concave up from 0 to 4. And then the function is going to be concave down from -1 to 0. Okay, let's try to draw the graph of f double prime. Okay, so we had all that information about f double prime right there. It's positive from -3 to -1. It's negative from -1 to 0. And it's positive from 0 to 4. We can be a little bit more specific, because remember, the derivative of this thing, or the second derivative, is the slope at any point. So if you notice over here, the slope is always +1. +1 is the slope. Here, the slope looks to be about -1, and then it just keeps getting bigger and bigger and bigger. -1 to 0 to +1. Okay, so if I'm going to draw the graph of the second derivative, or the derivative of that picture up there, -3, -1, 0, 4. Okay, it looks like from -3 to -1, it looks like this. And then it jumps up, oh, sorry, should be +1 there. +1. This slope right here was +1. Okay, then it jumps down to -1, and it goes up, kind of like that. So this is the graph of the second derivative, or the derivative of the picture above.